semester review that I was looking at.
All right. The ones you can verbalize?
Yeah. So the first one is x squared minus 1 over x, and that is over x squared minus 2x plus 1, and that's over 2x squared plus x.
Okay. When you're dividing, how are we going to divide the top fraction by the bottom fraction?
Don't you multiply it by the reciprocal?
Yeah, so let's just set it up like that to begin with. And now we're looking at a bunch of terms, 3 of which can be factored. In other words, I can factor that, I can factor that, and I can factor that. So let's do so, and then we'll cancel whatever we can cancel. So x squared minus 1 factors into what?
I don't know how to do it, like, when there's not...
That is called the difference of perfect squares. Let's talk about that, because that comes up a lot, and you want to be able to recognize. So
Okay.
a squared minus b squared always factors to a minus b times a plus b. Okay? So if I had x squared minus 1, a is x, b is the square root of 1, which is 1, times x plus 1. Okay? If take something like 4x squared minus 16. Or better yet, let's do 4x squared minus 25. How would that factor?
2x minus 5 and 2x plus 5.
Good. That's all you need to look. Whenever you see a quadratic that does not have an x term in it, most likely it's going to be the difference of perfect squares. That's all they are going to give you. In other words, you're not going to see something like this, because 2 is not a perfect square number. Okay? So as long as they're both perfect squares, you can factor it. So we'll factor the top left into x minus 1 times x plus 1. Going to leave x in the denominator. What can I factor from that expression?
Would it be... Well,
Think greatest common factor. In other words, whenever you're dealing with quadratics, the very first thing, with anything, quadratics or anything else, the very first thing you want to look for is to see if you can take a greatest common factor out. Okay? And this one you can. And in fact, they have 3 different types of extremely common situations here. We've got the difference of perfect squares, and then we've got this where we can factor what comes out of that. What can I pull out of that?
2.
Not 2, or x. In other words, I can only factor something out that divides evenly into both terms. 2 divides evenly into that term, but it doesn't divide evenly into that. But x does. When I pull an x out, what do I have left behind?
X.
Always remember that whatever I write right there times x has to equal 2x squared.
So then 2 plus
2x. That's the first step. In other words, the moment you figure out what the first term is, what you should be doing is multiplying this back together again to make sure that you didn't change it. Okay, that's a key part of division, is making sure you multiply the 2 terms back together again to get what you started with. And then what goes here?
1.
Okay. And then the bottom is a standard quadratic that factors. I don't know how you've learned to factor, but do you know what that bottom factors into?
Is it x minus 1 and x minus 1?
Yep. Okay, now we're ready to cancel. So anything that's the same, we can cancel. In other words, I can cancel that x minus 1 with one of these x minus 1s. I can cancel this x with this x. And when I say cancel, I really don't mean cancel. I mean divide top and bottom by that, leaving a 1 behind. Okay. So now what am I left with? The only numerators I have are x plus 1 there and 2x plus 1 there. And in the denominator, I still have an x minus 1 from this one right here. Okay? Now, I can't simplify this anymore. It might look like I can, but I cannot. In other words, I can only cancel same things, except with one exception. And the one exception is if, in other words, usually the only time I can cancel is if I got an A plus B, that exact same thing. But every now and then they give you one, and whether you are going to get one or not, I don't know. But if I had A minus B divided by B minus A, that is equal to minus 1. In other words, this is the only situation where you can cancel even though the two terms are not the same. And by that I mean if I had something like 3 minus x divided by x minus 3, I can change the x minus 3 to a negative 3 minus x, and then I can cancel, leaving minus 1 behind. But in general, you can only do same. In other words, I can't do anything with this x plus 1 divided by x minus 1. No way to simplify that. Same thing with the 2x plus 1. I can't do anything with this x plus 1 over here. I mean, I could multiply them back together again, but there's no point in doing that. You might as well leave the answer in factored form. It's almost better in factored form than it is multiplied together. So this is what your answer would be there. Okay. What else?
The next one, I have like 3 problems that deal with graphing systems of inequalities.
Okay.
So the first one is y is less than or equal to 4x plus 16.
Okay.
And then y is greater than negative 4 over 3x minus 4.
Like that?
Yes.
Okay. The first step in graphing these is to kind of graph it as an equality. In other words, we know how to graph y equals 4x plus 16, right?
Yes.
Okay, that would go through a y-intercept of 16 and would have a slope of 4, which is up 4 to the right 1. Okay? So draw that line, and it's definitely a line. It's a linear function. And now, because it's an inequality, we have to figure out whether that's a solid line or a dotted line and which side of it to shade. Well, is it solid or dotted?
I don't remember which one is
solid.
which.
Solid goes with the less than or equal to. This one's going to be a dotted one. Okay, you with me? Yeah. Now, which side do I shade of the top?
Like the right side?
Yeah,
the lower.
You really kind of want to say the lower side, not the right side. In other words, we're going to determine which side to shade based on the y-axis. I'm only going to look at the vertical axis. That's the y-axis, okay? And it
Okay.
says it's less than this line, so I'm going to find a point on the vertical axis less than that line. That tells me which side to shade. You were right, it's the right side, but it's important to look at it as where it is relative to the y-axis.
Okay.
So I'm going to shade that side for the first inequality. Now let's graph this. And initially, I better take my shading out, otherwise we won't be able to figure out what line. Here, let me do something like this. Okay. All right. Now let's graph this as a straight line. Well, where do I do that? Where do I start?
-4 y-intercept.
-4. Okay. That's it. -4. And what's the slope on
it? Down 4 and then to the left 3. Or to the right 3.
Yeah, just always make sure you end up with the right direction slope. Had I gone down 4 and left 3, that would have been my line. That's a positive slope. Okay? So you can get there all kinds of ways. I can go up 4 and over 3 to the left. But most people generally say up and over, and you really need to specify up or down and left or right. So I can get that same line by going down 4 to the right 3, graphing that point right there, and then connecting it. And this time I'm going to use a dotted line. Now, which side of that dotted line am I
on? Above it.
Above it, exactly. In other words, the only thing I care about is I go to the y-axis, I find a point that's greater than the line, right there. That tells me which side to shade. So my result is whatever area is covered by both graphs, and that is this area right here.
Oh, okay.
In other words, that part of the coordinate plane is in both graphs. And that's how you do these. All right, what's the next
one? Okay, the next one is y is greater than x squared minus 2x minus 3.
Okay.
And then y is less than or equal to 3 over 4x plus 2.
Okay. The top inequality, that's a quadratic. So that's going to be a parabola. The bottom inequality is linear. That's going to be a straight line. Okay? So to plot that quadratic, well, if I factor that, I can see that it's x minus 3 times x plus 1. Well, x minus 3 times x plus 1 is a quadratic that has these as intercepts, 3 and -1. In other words, I know that that parabola is going to go through that, and it's going to go through that point. Well, that tells me quite a bit about how to graph it. I know it opens up, and so it's going to look something like this. I don't know precisely where the vertex is, but actually I do. I know that it's halfway in between those two x-intercepts. So the vertex, the x-coordinate of the vertex, is going to go right through that point 2. Excuse me, not 2, 1. I didn't find the midpoint properly. And that is going to be a dotted line. I've incorrectly drawn it as a solid line. It's dotted because of that. Which side of that do I shade?
Above it.
Yes. Okay, so now I don't know how accurate these graphs need to be. In other words, I didn't figure out what the y value at the bottom of the parabola was. I can do it easy enough by just plugging in the x value, 1, into this. So when I do that, I get 1 minus 2 minus 3, that's minus 4. So I know this value right here comes at minus 4. And now I know exactly what that parabola looks like. It has x-intercepts at minus 1 and 3, has a minimum value at minus 4, and it opens up. And I've shaded the proper side of it. Now let's do the bottom. Well, because that is less than or equal, I'm going to graph a straight line. Where do I start my straight line?
+2.
That point right there. And get the slope how?
Up 3 and to the right 4.
Okay, and that is a positive slope. And that is also a solid line. Which side of that line do I graph?
Below.
Okay, so my area of joint is this area right here. In other words, you always want the solution to these is always the area that is shaded in both, from both functions.
Okay.
Okay, and sometimes there isn't any. It depends on the two functions, but usually they're not going to give it to you unless there's some overlap. But there doesn't have to be. In other words, if I were to say, instead of making that greater than, let's make it less than, well, then there still is going to be some overlap area, but where would I shade the first one? If I said less than, where does that include?
Below that.
But notice that below is definitely correct. In other words, I look to the y-axis, I find a point below, so I got a shade there, but you're actually shading all of that.
Oh, yeah.
In other words, anything on this side of the parabola has to be shaded. All right, what else you got?
Okay. I have an equation which is 6y minus 1 over y minus 2 equals 3.
First step?
Get a common denominator?
That's going to make the problem harder than it needs to be. We could do that. In other words, I could get a common denominator and carry out that process. But watch how much easier it is if I add 2 to both sides first.
Okay.
Turns that 3 into a 5 and gets rid of that 2. Now I don't have to worry about common denominators. What's the next step?
Times 5 by y.
Yeah, multiply both sides of the equation by y. Okay, well, when I multiply that side by y and that side by y, these y's cancel. So now I have 6y minus 1 equals 5y. We're getting closer. We don't have any denominators anymore. What's the next step?
Subtract 6y from the left side, and, well, from both sides.
I know that's the natural thing to do because it's one step, but actually there's 2 steps that are going to be involved. If you did that, what would the next line be?
-1y equals -1.
Right. In other words, all those negative signs. Let me suggest to you that if anybody wants to cut down on mistakes, that you try to leave the signs positive if you have a choice. Well, how could I leave the signs positive? I could move this 1 to the right side, and I could subtract that from the left side. That leaves you immediately with the answer.
Oh, okay.
It was still 2 steps. In other words, I had to add 1, and then I had to subtract 5y, so it was actually 2 steps. But notice, if we do it the way you suggested, it's still going to be 2 steps. It's -1 equals -y, but I don't have the solution yet. I got to divide both sides by -1 to get y equals 1. So it's 2 steps either way. The problem with this step is it's really easy to make a mistake when you have all those negative signs. It's easy to forget that negative sign when you move the 6y over, and it's easy to leave a +1 there. There's just, whenever you have more negative signs than you need, you're opening yourself up to errors.
Okay. Yeah, that makes sense.
Sometimes you don't have a choice. In other words, if I have 6y equals 1 minus 5y, no, I can't even think of an example one where, in other words, sometimes regardless of which way you move things, you're going to end up with a negative sign, and you just have to deal with it. But when you could do it one way and end up with 2 negative signs, or do it another way where you end up with nothing but positive signs, I would always do the positive sign.
All right.
Okay. What else?
So this one says, decide if each of the following functions has real or complex roots.
Okay.
And the first function is y equals 3x squared plus 5x plus 4.
You know the quadratic formula.
X equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
Very good. This part right here has its own name. It's called the discriminant. The reason it has its own name is because you can figure out whether a quadratic has real or complex solutions by merely analyzing the discriminant. In other words, we don't have to solve it to figure out if it has real or not. If what's inside the radical is a negative number, it's going to have complex solutions. If what's inside the radical is a positive number, it's going to have real solutions. So the only thing we have to really figure out is what b squared minus 4ac is.
Okay.
So what is b in this case?
5.
So b squared is 25 minus 4 times a is what?
3.
And c is what?
4.
Is that a positive or a negative number?
Negative.
Means we have 2 complex solutions. Complex solutions always come in pairs. You can't have just one. If you have a complex solution, you have to have 2. Okay? If that number would have been positive, we would have had 2 real solutions. And the only other choice is if that number is exactly equal to 0. If b squared, if the discriminant is exactly 0, and that means you have exactly 1 real solution. Because what you would be left with is just that. That's 1 solution only, and it's going to be real. It's not going to be an imaginary number. Okay? What else?
There's one more of one of those, if we could do one of those. 3x squared, y equals 3x squared, plus 5 minus 4.
Plus 5x minus 4.
Oh, yeah, sorry.
Okay, so what's the discriminant again?
B squared minus 4ac.
So for this problem, what is that?
That's going to be 5 squared minus 4, or minus 4, and then 3, and negative 4.
Now, what I always tell everybody is that when you're solving this, whether you're solving the entire quadratic for an answer or if you're just solving the discriminant, it doesn't really matter. But this is another situation where it's really easy to make a mistake. This is always subtraction. And when there's a negative sign with one of these three numbers over here, it is real easy to make a mistake on it. So what I tell everybody to do is to always carry that out first. Then whatever number you get, subtract it from b squared. So what is that number going to be? And it's all you really need to know is whether it's positive or negative.
Isn't it negative 48?
Well, this is negative 48. So what's the discriminant going to be?
Negative.
Oh, it's going to be 25 minus a negative 48. Those two negatives become a positive. Becomes positive 63, meaning we're going to have two real solutions.
Okay.
Okay? And that's something you got to watch for because, like I said, this is always negative. By definition, it's b squared minus 4ac. So if either a or c are negative, you're going to be looking at always this situation. And this situation becomes a plus.
Okay.
Okay? But the way to do it is to always multiply those three numbers independent of that negative sign. In other words, I didn't put that negative sign in a square because this is always negative. So we're always going to be subtracting whatever we get. So if what I have in a square is negative, that means we're actually going to have a positive number. If what I have in the square is positive number, then it depends on whether it's bigger than 25 or not as to whether we're going to have a negative discriminant.
Okay. Yeah, that makes sense.
And another thing about that, it's real easy to misread this. When you're doing this, if you're in a hurry or something, or if you're taking a test, it's real easy to say 25 minus 4 times 3 minus 4 and treat that as subtraction because it looks like it could be, right? I mean, it would be real easy to do 4 times 3 minus 4. Instead of multiplying those three numbers, you would end up subtracting that. That's the mistake that people can make. But the bigger mistake they make is not putting the two negatives together to turn it positive. In other words, the mistake you made was very, very common that people would make doing this. All right, what else you
got? I have one of it's 3i times 2i in parentheses. And I think I know how to do it, but just to double check since we don't have much time.
Okay, so what's the first part of the answer? 6 what?
It'd be 6i squared.
Correct. And then what is I squared going to be equal to?
Negative 1, right?
Correct. So this turns into negative 6.
Okay, so I just multiply them then?
Multiply each part. In other words, it's the same thing as if you had 3x times 2x. 6x squared.
Okay.
Okay. The secret is in how in converting the I squareds. You always end up with I squareds when you do these, and that's always negative 1. Now, working with complex numbers is very, very straightforward. If I have 3 plus 2i and I add it to 4 minus 5i. Just add the real parts together, 7, and the imaginary parts together. There's your answer. Okay? That's if it's plus. Subtraction would be the same thing. Subtract the real parts, subtract the imaginary parts. Multiplication. You know how to do that? We just did one. The only thing that's hard is division. When you have this. Do you have one like that?
I don't on this worksheet.
I can't imagine you wouldn't have to know this. It's a little tricky as to how you do it. You don't divide. What you do is you multiply by the conjugate of the denominator. In other words, if I multiply this by 4 minus 5i, the bottom, I'm going to get rid of the imaginary number. Well, if I multiply the bottom by that, I got to multiply the top also. When you multiply an imaginary number by its conjugate, it turns into a real number. In this case, it turns into 16 minus 25i squared, which becomes 16 minus a minus 25. That becomes 41. So that's our new denominator. Our numerator, you would FOIL those two together. That times that. Just, you know what I mean by FOIL? Not everybody uses that expression anymore, but
yeah,
you're going to multiply every term by every term. Well, let's do that real quick. 3 times 4 is 12 plus minus 15i plus 8i minus 10i squared. Notice the I squared is always going to turn into minus 1. So now when I simplify the numerator, I have a 12 minus a minus 10, so that becomes 22. I have minus 15i plus 8i, so that's minus 7i. The denominator is 41. So your answer almost never looks like what you started out with. Notice we started out with 3 plus 2i over 4 plus 5i, and we end up with this. Well, what you don't ever want is an imaginary number in the denominator. It's similar to having an irrational number in the denominator. If I gave you a problem like that, you would never turn that in as an answer because it's got an irrational denominator. So how would I handle that? What do I do when I have an irrational denominator? I rationalize it by doing what?
Squaring both.
Well, no, you can't square top and bottom. That changes the value. In other words, my goal is to change that fraction without changing its value. And I can only do that by multiplying it by the number 1. Well, square root of 2 over square root of 2 is the number 1. So this will change it without changing its value, but the answer becomes square root of 2 over 2, which is satisfactory because now the irrational number is in the numerator, and I have a rational denominator, and that's what you want.
Oh, okay.
Okay, so a similar thing applies to complex numbers. You do not want a complex number in the denominator. If I had 2 over I, that's not a satisfactory answer. Okay, but if I multiply that by I over I, well, now I have 2i over I squared, which is negative 1, which means the whole thing is just minus 2i. So 2 divided by I is the same as minus 2i. Okay? And in this case, I didn't multiply by the conjugate, but typically, if you have a full complex number, like 4 plus 5i, you know what I mean by the conjugate, right?
Yeah.
Okay. That's the only imaginary numbers that are hard, is division, because you have to do that process. Multiplication is easy, addition is easy, subtraction is easy. What else you got? Actually, we're over the time. I mean, I'm happy to go longer if you need more time, but we don't have to.
No, that's all right. That's actually like the only ones that I had circled on my packet.
Okay.
So.
Cool. Well, when's your final?
It's actually Thursday, so I was gonna schedule one for tomorrow if you had any time available.
Yeah, I do. Same time work, or do you want earlier? I can do 7 o'clock. I could do 7:30. I could even do, well, I'd rather not do something between 3 and 5. I'm gonna.
Yeah, 7:30 is perfect.
7:30 works.
Yeah.
You got it. Tomorrow night. I'll send you the meeting ID number at 7:30.
All right, awesome. Thank you so
You're
much.
welcome, Colin. Talk to you tomorrow.
All right, bye.
Bye-bye.